Greetings everyone, in today's video we'll show you how to create a helicopter system for 2D games. This system will cover all the aspects related to physics, controls, audio systems, animation and particle system. This is Ramez Al-Tabba from Binary Lunar and let's get started. Create new 2D project, let's name it 2D helicopter system. Okay, let's start simple by doing simple shapes to the shapes. So we can start with creating a square, simple square. We'll use that square to create the ground and the dummy for the copter for now. So we can name this square ground to create the ground. Just resize it and replace it. Okay, now this is a ground. We'll use another square copter dummy to represent the helicopter for now while we do the logic. We can make the ground darker. We need to add for the ground a box collider so the copter can hit it. Box collider 2D, of course. Also for the copter we need box collider 2D and a rigid body to gain access to the physics of this game object. Rigid body 2D. And we need to create a script called helicopter system that will control everything. We will use the physics to push the cube or the square up when we press W, and when we release the button we go down. So we need to access the following things. We need a public parameter to decide what is the speed, private rigid body 2D to access the physics of the square. I will name it RB, and the reference for it of course will be RB. We search for get component, we get the component on this game object which is rigid body 2D. Okay, so simply if we press the W button, so if input, that means we pressed up, we do the following. We access the rigid body and we add a force upward, and we will use the transform dot up as a direction for the force, and we will use the engine speed or force. Let's name it engine force better, I think. Engine force, and we multiply that with the direction, the up direction, then we multiply time dot delta time. I think that's enough for the basic logic. Let's save. Nothing happening because we didn't set the force. It should be based on my experiments. 1K is the best value, so let's set the engine force to 1K. 1K here, hit play, and it should work now. Yeah, that's nice. Now we need to do the rotation logic. So what we need is a float to control the rotation force. So let's create public float rotation force equals to 50 based on my experiments. We just need to do some other ifs. So if we're pressing the D, which means we're moving to the right, this time this square transform and execute the rotate function based on vector 3 forward. We multiply that with the rotation force over time. We do the opposite when we press the A button. So let's copy this just to change the button to the D and change the direction to back. Yep, it's working good. We just need to flip the direction of the rotation So when we press D, we do back rotation, and when we press A, we do forward. Okay, since the basic logic is ready now, let's add some graphics to the copter. My friend Muhammad Taha provided me with all the graphics and animations for this tutorial, so he created this nice cartoonish copter for me. Let's just replace the copter dummy from the square and pick this nice cartoonish copter. We just need to adjust the box collider by doing some offset to the left and some offset down a bit. We need also to add the fan, which is the main feature of the helicopter. We go to 3D and we rotate on the x-axis. See, something like that. Let's go back to the 2D, lift it above to be in the correct position, and we can set the layer to 1 to be above main copter body layer. Okay, and we should make it as a child of the copter. Now they're moving as one object. Let's start coding. What we want to do is to rotate this. We need a reference to the fan, so let's do public transform. We need to access the transform which have the rotation and say it's fan. And simply we can do this code. We want to do a rotation regularly, so the fan dot rotation, or rotate, we call the rotate function. We do a rotation on the z-axis, so it's 0 on the x, 0 on the y, and on the z, we need some parameters first. We need public float max fan speed, which equals, based on my experiments, to 2k. We need also a private, we can say float, or you can make it public, but it's better private float to check the current fan speed. So we always do a rotation based on the current fan speed, and we multiply that by time, dot delta time. When we press the W button, we need to increase the speed of the fan from 0 to the maximum speed, and when we release the button, we do the opposite. So we will use here the mathf.lerp to control the current speed of the fan. So we say the current fan speed equals to mathf.lerp. We do a lerp from the current value, which is the current fan speed, to the maximum speed of the fan over time. We do the opposite when we release the W button. So we say here else the current speed, we do a lerp from the current speed to the 0. So that will turn the fan off. First we need to assign the fan to get its transform, so drag it to the fan slot. Let's hit play, and hopefully it works from the first time without any issues, exactly as expected. Now when I press W, the fan starts moving and we are flying. When I release the W button, the fan stops rotating, and that's perfect. Now let's add some sound effect. First thing we need to do is to add an audio source, and I already got a helicopter sound effect from the internet. I'll provide you with the link in the description. So let's hit play, and I want to tell you what parameters we want to control. When I hit play, we will control two parameters. The volume, I will control the volume, so the volume goes to 0 when we stop moving. We will increase the volume as we keep holding the W to increase the sound of the engine. The second thing to control is the pitch. As the fan slows down, it goes into slow pitch to 0 when we stop, and it increases to 1 as we're moving on. So here is the trick we will use. To control those, let's go back to the script. First thing to do is to have access to the audio source, so private audio source. And let's set the reference to the audio source on this game object. So audio source, we need a private float to control the volume, so sound effect vol, and we need also private to control the sound effect pitch. Let's set those to 0 when we start to and let's control those the same way we control the fan speed. So we can copy that line. Actually, the sound effect volume, we do a lerp from the current value to the 1, which is the maximum volume when we keep pressing the W, and that's over time. The opposite happens when we release the button. So we do a lerp from the current volume to the 0. Same thing applies for the pitch, so we can copy those. And we just use the pitch here. We lerp the pitch from the current pitch to 1 and do the opposite when we release the W button. So we lerp to the 0. Now we calculated the volume and the pitch values, but we didn't set them to the audio source. So let's go to the audio source dot volume and set the volume to sound effect volume, audio source dot pitch, sound effect pitch. Okay, let's save and check if this works perfectly. I'll check those parameters, the volume and the pitch. We should start with no sound. That's good. And as you can see, while I hold W, the volume increase and the pitch start increasing. When we stop, we get that nice slow down pitch, and that's perfect. Let me increase the mass of the copter so we can move up more without flying so high. So maybe 1.8 on the mass. I think we reach now a satisfying results. Yeah, it feels nice, to be honest. You got now a realistic helicopter sound effect. Okay, to add some spice ups, we can create a particle system and control it via code also. So let's create a particle system, effects, particle system, and that will be a shape of circle since we are into the project and we want it to be 45 degrees, and let's rotate it to up. I want to smoke 60 seems good. Let's reposition it to be at here. Let's change some parameters. The color over lifetime, I believe. So we want it to start transparent, become then a bit visible, then go fully invisible. So we start invisible, in the middle let's set 125, at the end is 0. And now we got somehow a nice smoke. What we need to control is the emission over time. So we need to set it to 0 when we don't hold the W and set it back to 100 when we hold the W button. So let's go back to the code, have an access to the particle system. Let's go to public particle system. Simply when we press the W, we create a new variable emission, and we gain access to the emission on this particle system by calling the particles dot emission. Then we say emission equals to 100. That's when we press the W. When we release the W, we gain access again to the emission and set the value to 0. But I got an error here because we should say emission dot rate over time, and that's it. Drag the particle system to its slot in the inspector, and now we should see some smoke. And exactly moves when we press the button. Nice. Yes. The final thing we need to do is to add some fun by adding some animations. My friend Muhammad Taha created all the animations for me, and I send him big thanks for this. Of course, you can use everything as Patreon for training purposes and not for commercial regarding this project, because we might proceed with continue developing this into full game. So let's go to the animations and create a new animation. We create a new folder to hold the animations. Animations engine on animation. We have an animation when the engine is on. So let's go to sprites. I will drag all the sprites related to the animation on here. If I click play, see this nice engine on animation. You'll see it when we link it to the code soon. We need also, or Muhammad suggested that we do a land animation when the plane hits the ground. So a little squishy thing happened to the plane. Landing animation. And we drag all the landing sprites there. See, the landing when it hits the ground is do that little squishy thing. Okay, to see it more visible, we can reduce the frame rate to 30. Also, one more thing, the landing animation is not a loop, so we select that animation from the project files and uncheck the loop time, so it's one loop. The next thing to do is to go to the animator. As you can see, we have now two animations, the engine on and the landing, but we need also a third animation for being static without doing anything, which it will be the default state. So let's create a third animation called static. It will contain only one frame when we don't press anything, and it should be the default state. From that state, we go to the engine on animation by using a parameter or a bool called engine on. It's case sensitive. We'll use it in the script, so be careful. So we say we go from static to engine on when the bool is on, the engine on is true. We go back to the static state when the engine on is false. We can set the exit time, disable it, and set small transition to allow immediate response when we release or press the button. Then we can do a transition to the landing from the static or from engine on when we hit the ground, and we'll use for that a trigger. So let's create a new parameter. It's a trigger, let's call it landing. And we go to the landing when this trigger is called. So landing here and landing here. Once we did the landing animation, we exit from it. I think that's all related to the animator. Now let's code the animations and call those parameters from our code. So let's go back to the helicopter system code. First thing we need to do is we need some bools. Let's make them public so we can see the results in the inspector. We need a bool called grounded, and we need another bool called landed, and I'll tell you in a second why we use those two bools. Because when you are grounded, you might have triggered the landing animation already, and we want to trigger it once. That's why I created two bools for this. And we need an access for the animator to private animator, and we give it a reference to the current animator on the game object. So animator. Okay, so for the engine on and off animation is easy code. So we just access the animator and we trigger set bool, its name engine on, case sensitive, to true. That means the engine on, and we should start the engine on animation. The opposite happens in the else. When we release the button, the animation should stop, and we transition to the static animation. Regarding the landing, or the landing animation, we have two conditions. We should be grounded and not landed. When that happens, landed equals to true, so we don't trigger the animation again, and we animator dot set trigger landing, it's case sensitive. But to control those parameters, we need a raycast. A raycast is something of detection thing in Unity to detect if we collide or hit something. This check is necessary to check, for example, for checking if we are grounded or not. So let's do this. Let's go to the end of code and cast a raycast. Then use the results as a bool. So if not physics 2D dot raycast, the position is the current position. So transform dot position. The length, the direction should be to the down. We will use minus, means the opposite side of the vector 3 up, that means down, because there is no vector 3 dot down, so we use minus vector 3 dot up. And the distance, we should add here a float. Let's make it private float. Or you know what, we don't need a parameter, so since it should be always something, so that's the length of the ray which being casted. Then we need a layer mask, so we should specify which layer we should detect the collision of the ray casted. So let's create here also public layer mask. We will detect if we are hitting the ground or not, so we should add a new layer and assign the ground to it. And here should go the code. If we are not hitting anything, so grounded equals to false, that means we are not grounded. Also landed should be false. Else, if we are not hitting something, or sorry, else means we are hitting the ground, we should set the grounded bool to true. Save, and we just need to create a new layer here, add a new layer, let's name it ground, and assign the ground to the ground layer. And from the code, don't forget to set the layer mask to ground, because it by default set to nothing. The moment of truth, let's maximize the screen so you can see the nice animations provided by Muhammad Taha. Now the helicopter jiggling, or I don't know what we call this animation, this cartoonish nice animation while we're flying. Also, I'll remove the W button so you can see the landing animation when the helicopter hits the ground. Watch. Just a small squish thing. And that's all for today's tutorial. I hope you enjoyed watching with me. Don't forget to hit like, subscribe and share this video. We are deeply thankful to our supporters on Patreon: Cody Brunti, Damiano Cerenzi, Joseph Miaulin, Norbert Gorfol, Andres Philip, Ether the Skylord, Gustavo Augusto, Panda Owl, Brian Foneman, Zhen Yang, Rami Hanano, Chen Ran Ying, Ning, Sky Rolnik, Kijou, Darius Kurantis, Jose Enrique, Mohammed Aydin, Sergei Markushin, Pira Chembunchim, Kev Tesler, RTS Shaharbar, Oklisi Fix, Dimitri Vasiliev, Breadman, Joshua Kratoshville, Parker Nelson, Giacomo Mariani, Joss Lefevre, Pedro, Jens Valentine, and Jack Weston. Till next video, see you soon.